report on this computer. Okay, so let me go ahead and just put the basic question out there. So here it is, the probability of diamond or 7. So now what you need to remember about this is you need to remember the addition rule, right? The addition rule says that the probability of A or B must equal the probability of A plus the probability of B minus the probability of A and B.
Good morning. Sorry for the interruption. Do you have Arguelles Nicolas there?
I do?
Nicolas Arguelles?
Yes, yes,
Can you please send him to the main office for a second?
of course.
Thank you.
All right, so now if you remember from last class, we said that, you know, when the events are not mutually exclusive, we use that. I mean, technically we always use it, but we remember that when two events are mutually exclusive, then the probability of A and B equals to 0, right? And when that happens, then the probability of A or B just equals the probability of A plus the probability of B, because this just became 0, right? So you don't have to write that. I'm gonna go ahead and erase that. But if it's mutually exclusive, we don't worry about A and B. So let's talk about whether this part A is exclusive, mutually exclusive or not. Can you be 7 and diamond at the same time? Can you be a 7 of diamonds? So these two events, diamond and 7, are not mutually exclusive. So you go ahead and just write probability. Let me zoom in here because it's zoomed out. Oh, wait. Here we go. We have the probability of diamond plus the probability of 7 minus the probability of diamond and 7. So what's the probability of diamond? There are 13 diamonds. Remember, there are 13 diamonds, there are 13 hearts, there are 13 spades, there are 13 clubs. There are 26 reds, there are 26 black cards. Remember that. What's the probability of getting a 7? Yep. And now, quick question. Are any of those 7s a diamond? 1. And do you notice that we ended up counting it twice? In here, we already had counted that diamond, that 7 of diamond. So we're going to have to subtract 1 out of 52 here. So there are 17 minus 1. There's 16 out of 52. 16 divided by 52. There's 16 cards that meet the criteria of diamond or 7. Make sense? That's why we do that part. Because now we end up counting that 7 twice. Does that make sense? We have a 2 of diamonds. We have a 3 of diamonds. We have a 4 of diamonds. We have a 5, a 6, a 7, an 8, a 9, a 10 of diamonds, a J of diamonds, a queen of diamonds, a king of diamonds, an ace of diamonds. That's 13 cards right there. But when I go ahead and say the probability of 7, there are 4 7s. And of those 4 7s, you got to allot for the 7 of diamonds I just counted. Does that make sense? Yes? No? Maybe? Let's do the next one. The probability of red or queen. Is it possible to be a red queen? Yes. So therefore, we had to allot. They're not mutually exclusive. We had to allot for that. We have to count that. The probability of red plus the probability of queen minus the probability of red and queen. So what's the probability of a red card? Out of? What's the probability of queen? There are 4 queens. How many of those queens, those 4 queens, are red? 2, which we would have counted already here. So 26 plus 4 is 30 minus 2, 28 out of 52. Take a look at the last one. Any questions, by the way? Are we good?
So you got 2 because out of the 4, there are 2
They're red. And I would have counted those in the first 26.
So it's not like it's always -1, but
Depending on the situation, correct. Look at the last one, the probability of 3 or face. Can you be, by the way, what's a face card? It's a J, a queen, or a king. Can you be a 3 and a face card at the same time? No, so these are mutually. Take care. What's your homework? Did you write this right now?
No.
Okay,
I just forgot.
I got you. All right, so go to nurse. Here's your homework. So these are mutually exclusive. So you just write probability of 3 plus probability of face. But even if you by mistake wrote this, and it's not a mistake, it just means that this is just 0 out of 52, right? So that's why we don't do it, because they're mutually what? Mutually exclusive, right? So let me erase that. So what's the probability of a 3? 4 out of? How about the probability of a face card? How many face cards we have? 4. 12. An A is not considered a face card. And there you go. Mutually exclusive events. That's all you do. Make sense? So armed with that, you should be able to do some of the other questions. I want to go ahead and do number 16, which I'll write here on the whiteboard. Yes.
So if they're not exclusive at line probably of A and B, and
Yep.
they are exclusive,
We don't. But basically, this here, part C, is just a special case of this. It's just this becomes 0. That's why.
Good morning.
Good morning.
May I please have JD Capote come to the main office?
I don't have her in class. During attendance, she wasn't here either.
Okay, thank you.
Oh, no problem. Okay, so let's look at number 16. Number 16 says can defects. A company that makes soda pop cans finds the probability of producing a can without puncture is 0.96. So the probability of, let's say, without puncture, WP is 0.96. And then it says that the probability can does not have a smashed edge. So the probability of not smashed is 0.93. And then it says, and the probability that can does not have a puncture and does not have a smashed edge is 0.893. So probability of without puncture and not have a smashed edge is 0.893. Part A asks, are these mutually exclusive? So it asks, are without puncture and not smashed mutually exclusive? And what will you guys say? Are they mutually exclusive or not? They're not mutually exclusive. Why? Because in order for this to be mutually exclusive, in order for WP and NS to be mutually exclusive, so we say this is not mutually exclusive. In order for WP and NS to be mutually exclusive. Oh, damn it. Nobody said anything. Here we go. But now you said it. So they're not mutually exclusive. And the reason is in order for those to be not mutually exclusive, we must have that this equal to what? What does this have to equal to for them to be mutually exclusive? They can happen at the same time. If they're not mutually exclusive, they can't happen at the same time. So what's this probability gonna equal to? 0. Is the probability of WP and NS equal to 0? No, it's equal to 0.893. So therefore, it's not mutually exclusive. Make sense? Make sense? And so all you gotta do is if and exists, if it's there, if it exists, if it's a number other than 0, then it's not mutually exclusive. If it's equal to 0, it means it can't happen at the same time. It can't exist. Can't happen. Therefore, we say it's mutually exclusive. Yes. If they overlap, then this exists. So is it enough? I would like you to understand that if this exists, it means it overlaps, which is good. But you just need to understand. Yeah, I see what you're saying. But it would be nice to see that in that question specifically, it would have been enough to say that the probability exists because it's 0.893. Therefore, it's not 0. So it's not mutually exclusive. Does that make sense? Sort of. But if they give you a diagram, then definitely you say they overlap, therefore they exist. There's an intersection, therefore they exist. And if they exist, if there's an overlap, right, then it's not mutually exclusive. Okay, part B says, if a quality inspector randomly selects a can, find a probability that the can does not have a puncture. So a probability of without puncture, or does not, or, and that's your key that you're using. The key word here, or, tells you you're using additional. Or does not have a smash edge, so not smashed. So we write that like this. And so we just say, okay, it's a probability of WP plus a probability of NS minus a probability of WP and NS. So probability of WP is apparently 0.96. And the probability of NS is 0.93. And then we have to subtract their intersection, their overlap, right? That's 0.893. So let me do the quick math here.
It's minus 0.893.
Yes. Yes. So we have 0.96 plus 0.93 minus 0.893. I got 0.997. So that's the answer. Make sense? Good? You guys are awfully quiet. I know it's cold, but notice I'm not wearing my sweater. I also have the windows to the room open. It's making me colder. It's not pleasant though.
Probably the same temperature out there than here.
Say that again?
It's probably the same temperature out there. than here.
It is. This room is always very cold. In fact, it's warmer outside than here. So let's go ahead and close this window just to make it more difficult on myself. Brian is not wearing a sweater either. He's testing himself. Or did you just forget your sweater? Oh, why do you take it off? Oh, okay. Oh, no, that makes sense. You are cold. All right, so I think those two questions are enough for you to. Is there any other question you want me to review? And this is page, actually, go ahead, page 166. So I'll put it up top here in the notes. Page 166. Any other questions? No questions, no questions.
26 or
26, I think it was. Yeah. No questions, wonderful people? Nobody has any questions? Yes. I'm gonna post that, and then next class we'll review it. And then you'll have as your first quiz next 9 weeks. Fair enough? So that's coming. So I'll probably, after I'm done with this, I'll post that, a practice quiz with practice questions, and that's it. No problem. Any other questions? Questions? No, 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 no. All right, those of you who didn't do your homework, please start working on it. I'll take a look at your work next class for some credit. It's better than nothing. And if you have questions, come up to me. I'm here. Fair enough? And obviously, those of you who did it, congrats. If you didn't finish it, because not everybody finished it, make sure you do it and come to me for questions. Yes, ma'am. To TV production.